College Algebra, Module 3, Topic 3.2, Equations of Lines. Objective 1 is slope-intercept form. The line with slope m and y-intercept b is given by the equation y equals mx plus b, which is known as the slope-intercept form of the linear equation. We'll start with an example. Write the equation of the line with a slope of -1/4 and a y-intercept of 5. Well, slope, if you'll remember, is m. The y-intercept is 5. So using your slope-intercept form, y equals mx plus b, we get y equals the slope, which is 1/4, times x, plus the y-intercept, which is 5. Example 2. Write the equation of a line that has a slope of -2 and passes through the point 0, 7. Again, they're giving us the slope, so we know that m is -2. The point 0, 7, well, remember the y-intercept is always 0, number, so our y-intercept for this problem is 7. Because we know a slope and a y-intercept, we use y equals the slope, which is -2, times x, plus 7, which is the y-intercept. So our equation is y equals -2x plus 7. For slope, recall that if x1, y1 and x2, y2 are 2 points on a line, then the slope can be found by using the formula m equals y2 minus y1 divided by x2 minus x1. Objective 2 is point-slope form. The line with a slope m passing through the point x1, y1 has an equation y minus y1 equals m times x minus x1. This book, like we mentioned earlier, chooses to use the formula y equals m times x minus x1 plus y1. Remember, they'll probably give you the slope and they will give you the ordered pair x1, y1. This is known as the point-slope form of a line because you use it when you know a point and a slope. So our first example of this. Write the equation of the line with a slope of 3 which passes through the point -1, 2. Write your answer in point-slope form. So we know that m is 3. We know that x1 is -1 and y1 is 2. Now point-slope form is y equals the slope times x minus the x value plus the y value. So we're ready to substitute in. Y equals the slope is 3 times x minus the x value, which is -1, plus the y value, which is 2. Cleaning that up just a little bit, x minus -1 is the same as x plus a +1 plus 2. So this is our equation written in point-slope form. Second example. Write the equation of the line with a slope of 2/3, which passes through the point 4, -5. This time we're going to write our answer in slope-intercept form. So we have slope is 2/3, our point, x1 is 4, y1 is -5. So we say y equals the slope, which is 2/3, times x minus the x value, so we get x minus 4, plus the y value, which is plus -5. Now because they tell us slope-intercept form, our y equals mx plus b, which means there's no parentheses, so we need to clean this up a little bit. So we get y equals 2/3 times x is 2/3 x. 2/3 times a -4 would be -8/3 plus a -5, so I'm just going to call that -5. Now we've got to go through and combine our like terms. So we've got a negative 8/3 minus 5 that we need to combine. So let's come over here. We've got negative 8/3 minus 5/1. Remember, to subtract fractions, you have to have a least common denominator, so we're going to use LCD of 3. Then we're going to rewrite both of these fractions with a denominator of 3. So 1 time goes into 3 times. 3 times 5 is 15, but that's a minus. 3 goes into 3 one time. 1 times 8 is 8, but that's also a minus. We get negative 23/3. So we get y equals 2/3 x minus 23/3. This is the equation that passes through 4, negative 5 and has a slope of 2/3. Third example, find the equation of the line that passes through the points negative 3, 7 and 2, 5. Write your answer in slope-intercept form. Whether we use point slope or slope-intercept, we need a slope. So the first thing we have to do, because they give us 2 points, is use the slope formula to find the slope. So we're going to call this x from the first point, y from the first point, x from the second point, y from the second point. So when we plug it in our slope formula, we get 5 minus 7 divided by 2 minus negative 3. So our slope is negative 2/5. Now, because we've got a slope and 2 points, and neither of those points is a y-intercept, we're going to just pick one. So because we've already got this one labeled as x1, y1, let's just use that one. x1 is negative 3, y1 is 7. So we're going to do y equals the slope times x minus the x value plus the y value. So y equals negative 2/5 times x minus a negative 3 plus the y value of 7. Distributing the negative 2/5, we get negative 2/5 times x. Got minus a negative here, which both of those are going to be plus a positive. So now we've got negative 2/5 times a positive 3. So if we need to come over here, negative 2/5 times a positive 3, multiply straight across, and we get negative 6/5. But now we've also got to add 7 to that. So we've got negative 6/5 plus 7/1. To add 2 fractions, we've got to have an LCD. So we're going to have a least common denominator of 5. So this one becomes 35/5. This one stays negative 6/5. So we've got negative 6/5 plus 35/5, which would give us 29/5. So our slope-intercept form would be y equals negative 2/5 x plus 29/5. Example 4. Find the equation of the line that has an x-intercept of 4 and a y-intercept of negative 6. Write your answer in slope-intercept form. So what we've got is we've got 2 different points, or 2 ordered pairs. The x-intercept of 4 is the ordered pair 4, 0. The y-intercept of negative 6 is the ordered pair 0, negative 6. So we start out, we need a slope. So we're going to subtract the y values, negative 6 minus 0 divided by, now we're going to subtract the x values, 0 minus 4, which gives us negative 6 divided by negative 4, which simplifies to give us 3/2. So the slope of that line is 3/2. Now in this case, we know the slope and we know a y-intercept. So because they give us y-intercept is negative 6, we know that b is negative 6. So we can just use our slope-intercept form, y equals mx plus b. So we get y equals 3/2x plus a negative 6, or minus 6. So this is the slope-intercept of a line that has an x-intercept of 4 and a y-intercept of -6. Example 5. Write the equation of the line for the graph shown below. Write your answer in slope-intercept form. So for this problem, we have a y-intercept right here of 5, so that is the ordered pair 0, 5. I'm looking down here at that x-intercept. I'm really not sure what that point is. I know that this point is a nice point on the graph, so that is the ordered pair over 1 up 3. So let's go through and use those 2 points, 0, 5 and 1, 3, to write the equation of the line. So we've got to find the slope, y2 minus y1, so that would be 3 minus 5, divided by, subtract your x is 1 minus 0, which would be -2 over 1, so the slope is -2. We also have the y-intercept, so we can just say y equals -2x plus 5. Objective 3, equations of horizontal and vertical lines. An equation of the horizontal line with the y-intercept b is simply y equals b, because for a horizontal line the slope was 0. For example, y minus 4 equals 0 can be rewritten as y equals 4. What this means is it does not matter what the x value is, the y value is always 4. So if we plug some points in, if x is 0, y is 4. If x is 2, y is 4. Therefore, it's a horizontal line. Also, we talked about it, the line with a slope of 0 means it's horizontal, and the y-intercept is 4. An equation of the vertical line with an x-intercept a is x equals a. In this case, you cannot write it in y equals form because there is no y. Therefore, the slope was undefined. Well, an undefined slope represents a vertical line. So, for example, x plus 2 equals 0 can be rewritten as x equals -2, which means you go to -2 on your x-axis and you draw a vertical line through -2. Let's do some examples of these. Write the equation of the horizontal and vertical lines passing through the point 4, 7. Well, if we graphed it, over 4 up 7 would look like this. The horizontal line would be right here, which we said a horizontal line is y equals whatever the y value of your point is. So that's your horizontal line. The vertical line would be right through here, which we said a vertical line has an undefined slope, so it's always x equals whatever the x value of your ordered pair is. So x equals 4 would be the vertical line. Well, we've talked about point-slope form, slope-intercept form. Another form is the standard form. An equation of a line is in standard form when it's written as ax plus by equals c, where a, b, and c are constants. What this means is you get the x's and y's on one side of the equation and the number terms on the other. Typically, we want the x term to be positive, and we don't want fractions for your coefficients of a or b. This is a nice, neat form of the equation. But it's not very useful, not like the point-slope or slope-intercept. Objective 4. Intercepts. We'll start with x-intercepts. The x-intercept is the point where the graph crosses the x-axis. The x-intercept will always be an ordered pair of the form x, 0. To find any x-intercepts, you let y equal 0 and solve for x. The y-intercept is the point where the graph crosses the y-axis. the y-intercept will always be an ordered pair of the form 0, b. And to find any y-intercepts, we're going to let x equal 0 in the equation and solve for y. Let's do an example. Find the intercepts of the line 2x minus 3y equals 12 and use them to graph the line. Well, to find the x-intercept, we are going to let y be 0. To find the y-intercept, we are going to let x be 0. I found when you're graphing lines using intercepts, it helps to go ahead and make the chart x is 0, find y is 0, find x. So our first ordered pair, let x be 0. So we have 2 times 0 minus 3y equals 12. Well, 2 times 0 is 0, so that term is just 0. So you get negative 3y equals 12. To solve that, we're going to divide both sides by negative 3, so we get y is negative 4. For the second part, we're going to let y be 0, so we get 2x minus 3 times 0 equals 12. In this case, 3 times 0 is 0, so that part's gone, so we get 2x equals 12. Dividing by 2 gives us x equals 6. So there's our two ordered pairs. So to graph those, we're going to go to our graph. The first point, 0, negative 4, means over 0, down 4. That's our y-intercept. Our second point, 6, 0, means you go over 6, up 0. That's our x-intercept. To graph that, we're going to draw the line that passes straight through those 2 points, and that's what the graph of our line would look like. Objective 5, parallel lines and perpendicular lines. Parallel lines have the same slant. Therefore, they will have the same slopes. Perpendicular lines have slopes which are negative reciprocals. Remember, perpendicular lines are two lines that intersect to form a 90-degree angle. For example, write the equation of the line that is perpendicular to the line y equals negative 1/4 x minus 2 and has a y-intercept of 8. Well, going back to our point slope and slope intercept form, either way we go, we need to find a slope. Okay? Well, for this line, we could sort of look at that. It's in y equals mx plus b form. So this line has a slope of negative 1/4. Because we're looking for a line that's perpendicular, we are going to use a slope that is a negative reciprocal. So the perpendicular slope, I'm going to use a little perpendicular symbol, would be the negative of which would be positive, the reciprocal of 1/4, which would be 4. So we're going to use a slope of 4. We also know that the y-intercept is 8, so what we're down to is we have a slope of 4 and a y-intercept of 8, so we use y equals mx plus b, which would be 4x plus 8. Our next example, write the equation of the line that passes through the point 2, negative 1 and is parallel to the line y equals 3x plus 2. Same thing. To write the equation of a line, we need a slope. Well, when they tell us it's parallel to this line, parallel means same slope. This line has a slope of 3, so we are going to use a slope of 3. And we're going to use the ordered pair 2, negative 1. So our point slope form says y equals m times x minus the x value plus the y value. So y equals 3 times x minus the x value of 2 plus the y value of negative 1. So cleaning that up, we get y equals 3x minus 6 plus a negative 1. Combining like terms, we get 3x minus 7. So this is the equation of a line that's parallel to 3x plus 2, but passes through the ordered pair 2, negative 1. Let's do another example. Write the equation of the line which passes through the point 5, 3 and is perpendicular to the line 4x minus 9y equals 11. Now this time, as before, we need a slope. Now this time, we can't just look at 4x minus 9y equals 11 and pick off the slope. So what we're going to have to do is get this one in y equals form, which means we're going to subtract 4x from both sides. So that would give us negative 9y equals negative 4x plus 11. We need y on a side by itself, so we're going to divide both sides by negative 9. So we get y equals negative 4x divided by negative 9 plus 11 divided by negative 9. Cleaning this up, we get 4/9 x minus 11 over 9. Now notice this is not our answer. This is the line that they're giving us, just rewritten in a different format. But now we can look at that and know that the slope is 4/9. Because we're looking for a perpendicular slope, we are going to use the slope of negative 9 over 4, and we're going to use the point that they gave us, which was 5, 3. So we get y equals the slope times x minus the x value plus the y value. Substituting our values in, we get negative 9/4 times x minus 5 plus 3, which gives us negative 9 over 4x. We've got a negative 9/4 times a negative 5, which is going to give us a positive 45 over 4 plus 3. Now the way we got that, we did negative 9/4 times negative 5 over 1, multiply straight across, and that gives us the negative 45/4. Now we're going to add 3 to that, so we're going to rewrite that as 3 over 1. LCD is 4, so that gives us 12 over 4 and negative 45 over 4. Adding those together, we get negative 33 over 4. So our final answer is going to be y equals negative 9/4 x minus 33 over 4. Objective 6 is interpolation and extrapolation. Interpolation is a form of estimation when an unknown point lies between known points. Extrapolation is a form of estimation when the unknown point is an extension of known points. For example, the U.S. sales of Toyota vehicles in millions is listed below. We have the years and we have the number of vehicles. The first question is this data exactly linear? Well, looking, we know that as the x's increase by 2 every year, the y values increase by 0.2 every year. So it's exactly linear because the rate of change every time is exactly the same. The next thing we want to do is write the equation of the line passing through these 3 points. Well, because it's exactly linear, we can choose any 2 of the ordered pairs. We can choose any 2 of the 3 ordered pairs. So let's say we just pick the first 2. So this is x from the first point, y from the first point, x from the second point, y from the second point. So to find the slope, we need the y2 minus y1, which is 1.6 minus 1.4, divided by 2000 minus 1998, which is 0.2 divided by 2, which gives us a slope of 0.1. To find the rest of the equation, we need to choose one of those points, so we'll just choose the first one, which is the ordered pair 1998 and 1.4. And we want to use the point slope formula to find that equation of a line. Now I'm just going to go up here to the top. So we get y equals the slope, which is 0.1, times x minus the x value, which is 1998, plus the y value. So we would get 0.1x minus 199.8 plus 1.4. So y equals 0.1x minus 198.4. So that is the equation of a line that passes through all three of those points. Now, so I'm going to rewrite that on the next slide to finish answering the questions. We get y equals 0.1x minus 198.4. Now we're going to use the model to predict the sales in the year 1999. So what we're going to do is we're going to take the year 1999 and plug it in for x. Y equals 0.1 times 1999 minus 198.4. So that would be 199.9 minus 198.4, which gives us 1.5. So that would suggest that the y value, or the number of vehicles, is 1.5. Is this interpolation or extrapolation? Well, because 1999 fits between some of the given values, then it's called interpolation. Now we're going to use the model to predict the sales in the year 2004. Well, rewriting our formula again, we get y equals 0.1x minus 198.4. This time we're going to plug the x value in for the year of 2004. So we get 0.1 times 2004 minus 198.4, which is equal to 200.4 minus 198.4, which is 2.0, which says that in the year 2004 there would be 2.0 for these sales. Is this interpolation or extrapolation, and why? Well, because 2004 is an extension of the data that's already given, then it is extrapolation. Objective 7 is linear modeling. The local football team needs to have a pregame meal for the players and coaches. The caterer charges a $20 fee to set up and then charges $4 per player or coach for the actual meal. Find a linear function that gives the cost for the meal of P players. So our function is slope, or the rate of change, is $4 per player plus a $20 setup fee. Because it says for P players, really we should have went the cost for P is equal to 4P plus 20, where P is the number of players. Now, what does the y-intercept on the graph represent? Well, if we graphed it and P was 0, then the first y value is 20. So that means the 20, or the y-intercept, is the cost for P equals 0 players. That is our initial value, and then the line would increase by a rate of 4 for every player or coach. The next example says, the table lists the average tuition and fees at a public college and university for the selected years. We want to find the linear function that models the data. So our first question is this exactly linear? So as soon as we find two numbers that shows it's not exactly linear, then we're going to go into our calculator and find our function modeling this data. So we're going to go into Stat, we're going to go to Edit, let's clear those lists. So we're going to go up to L2, hit Clear, Enter, then we're going to go over to L2 up at the top, press Clear, hit Enter. Now we're ready to enter our data. Now, before I start typing these in here, always look for this little statement because it appears a lot. Let x be the number of years since 1985. This makes the numbers a lot smaller and easier to work with. So that means this x value is going to be 0. This is 5 years after 1985. This is 10 years after 1985. 1999 is 14 years after 1985. And 2004 is 19 years after 1985. So when we enter this in our calculator, we're going to go 0, 5, 10, 14, and 19. Then we're going to do the same for our y values. Once we get all of the values in there, remember we go to Stat, we go to Calculate, and we choose option number 4, which was linear regression. Pressing enter gives us our formula, y equals 198.5 times x plus 974.3. Is this an exact fit? No, it's not, but it's pretty close. You notice r is 0.97 or almost 0.98, so it's very close to 1. So this is a pretty good fit. Then the next question says, estimate the tuition and fees in the year 2006. Well, remember, it's all based on the number of years since 1985. So 2006 minus 1985 gives us 21. So we're going to go into our equation and plug in an x value of 21. So we would get 198.5 times 21 plus 974.3. And that gives us 5,142.8. Because all of the data in our table are whole numbers, let's go ahead and round that one to $5,143. Objective 8 is variation. We're going to do direct variation now, and we will hit inverse variation later. Let x and y denote two quantities. Then y is directly proportional to x, or we could say that y varies directly as x, if there exists a non-zero number k such that y is equal to k times x. The number k is called the constant of proportionality, or the constant of variation. For example, if y varies directly as x, and y equals 9 when x equals 3, find the constant of variation. Well, always go back and look for your sentence, y varies directly as x. Varies directly means it's k times. The quantity they give you first goes first, and the one it varies directly as goes on the side with k. So for this problem, now they're telling us y is 9 when x is 3, so let's just plug it in. 9 equals k times 3. So 9 equals 3k. Divide both sides by 3, so we get that k is 3. Now they tell us to find the equation of variation. Well, we're going to take our y equals k times x, but now we know k is 3, so our equation of variation becomes y equals 3x. Now, what if they ask us to find y if x is negative 2? Well, we have our variation equation, so we're going to say y equals 3 times negative 2, so y would be equal to negative 6. So for these very directly problems, first thing you're going to do is find k. The second thing you're going to do is to find the equation, and then the third thing you're going to do is to find the value of what they're asking you. Let's do another one. If t varies directly as s, find t when s is 5.7. So we're going to start out, look for your statement that tells the variation. T varies directly as s, so that means t equals k times s. So So what they give us is a t and an s value, so we're going to plug that in. 3.96 equals k times 1.2. Dividing both sides by 1.2, we get 3.3. So our k is 3.3. Our equation now becomes t equals 3.3 times s. We're going to use this equation now to find t when s is 5.7. So t is 3.3 times 5.7. So using our calculator, gives us a value for t of 18.81. Okay, last example. The height of an object is directly proportional to the shadow cast by the object. If a person 59 inches tall casts a shadow 71 inches long, how tall is a tree which casts a shadow of 33 feet in length? Now remember, we did this one by a proportion earlier, but let's do it with our direct variation this time. We've got that the height is directly proportional to the shadow. So what that means is height equals k times s. So the first thing we're going to do is find k. So we're going to take the first information they give us. A person of 59 inches tall cast a shadow of 71 inches long. So the height is 59 equals k times 71. So our k is going to be equal to 59 divided by 71. I'll just wait and use my calculator here in a second. So our equation now is height equals 59 divided by 71 times s. And then the last part says, how tall is the tree? So we're looking for the height when the shadow is 33. So we get height equals 59 over 71 times 33. And now we can just plug it into our calculator and we don't have to worry about losing digits when we round. So inside parentheses, let's put 59 divided by 71 times 33, and that gives us a height of 27.4. So because we're doing everything whole numbers, let's just do height equals 27 feet. You know, I just realized that problem had a shadow of 33 feet. Probably not going to have a shadow of 33 feet. So what we need to do is we need to go back and change it in your notes to 33 inches in length. Sorry about that. Okay, you are now ready to do the homework for Module 3, Topic 3.2. Once you have a 90% on 3.1 and 3.2, you will be ready to take the Module 3 quiz. And remember, you must have the notes from both sections in order to take the quiz. If you have any questions, let us know.